Okay, are we ready? So when I talk about perimeter problems, I want you to write these 3 words: perimeter, area, volume, and then actually 4 words: surface area, okay? We don't get a lot of time to fit in geometry in here. I know you have a lot of it with Mr. Meeks in his class, but I like to try to fit it in when I can. We're only going to be talking about perimeter problems today, but I kind of just want to throw some of this in here anyway. So perimeter, here's my story that I talk about when I teach perimeter, area, volume, all this good stuff. So let's say summer's coming. I want to build a pool in my backyard. I want that pool to be an underground pool, and I want it to be a cube. So I want it to be the bottom of it 10 by 10. Okay, the reason I'm just going to choose that is because I have this little shape right here that I'm going to use to kind of simulate like the real life pool, okay? So here is this cube right here. So I have a 10 by 10. Well, I have little kids, so I don't want it to be just them able to walk into it. So I want a fence to go up around it, right? I know when you have a fence around a pool, normally it's like farther out, right? And there's like some sidewalk. I want my fence, and I need it to be this way for the sake of this problem, to be right up on the edge of that pool. Okay? Yeah, it's not going to be fun, but there's going to be a gate you can get into, okay? So when I go to the guy at Home Depot in the fence department and say, "Sir, I need some fence to put around my new pool. I want it to go right on the edge of the pool. I don't want any area around it." He would say, "Ma'am, what are the dimensions of your pool?" And I would say it's a 10 by 10. And so when he tells me how many feet of fencing I would need, what do you think he's going to tell me? If I need to go around, how many feet of fencing, Jana? 40, not 100, okay? Because look, I need 10 feet for this side, 10 feet for this, 10 feet for this side, and 10 feet for this. So if I had to pick one word that helps describe what perimeter is, it's the 2 words actually, the distance around. You got it, okay? It's the distance around things. All right? So the distance around here would be 40 feet. That's the perimeter of that. Okay, so then I get the fence up. Then I look in the pool, and it's just that ugly blue material. I want to put some fancy ceramic tile on the floor of that pool. Okay, so I have a 10 by 10 pool. Draw 9 lines. I go back to Home Depot. Instead of the fencing department, I go to the guy in the tile department, and I say, "Sir, I want to put some fancy tile on the bottom of my pool." And he's going to say, "Ma'am, what are the dimensions of your pool?" And I'm going to say it's a 10 by 10. And then he'll probably say, "What size tiles do you want?" Because that depends, right? For those of you who said 100, you're assuming that I want a 1 foot square tile, and I do. So if we were to think about what 1 square foot is, let me grab these rulers here. 1 square foot would be, does everybody agree that this is a foot? Yeah. And this? Yeah. And this? Yeah. Time is going to be my helper. And this? So if I take all of these feet, time is going to complete. That's a square foot. Hold it up. This is a square foot. So have you ever heard people talk about like how many square feet are your house? Or when real estate agents, it means make a square out of a foot. So when real estate agents try to sell houses, they say, "Ooh, I have a 2,000 square foot house. That means it's kind of big." Or I have a 900 square foot house. It's a little bit littler. It means that I could take 2,000 of these, lay them on every floor surface in that house. So that's the floor spacing of a house, right? You don't count the basement unless it has an access way to outside, right? And then you count the upstairs, you count hallways, you count bathrooms, that's everything. Okay, so this is a square foot. So if my pool is a 10 foot by a 10 foot, and I want my tiles to be this size, how many of these will I need? I will need 100 of them, right? Okay, Keegan, question?
If I were going to be like a real estate agent or something, then would I have to go around with 1,000 rulers
No, that's a great question. There is an easier way to do that. Okay? Do you have to go around and place squares on that? Go ahead.
There's tools that people use now, like real estate.
Yeah.
They take this like ruler wheel.
Yes.
And they just push
It's a wheel. They push it. You ever see those guys out on construction sites or when we...
Every time it turns,
Yeah.
it counts as one.
Yeah, it counts as one. So then, here's what they do. They measure the side length of one room, of one wall, and then the side length of the other. And area is what it takes to cover. So if perimeter is around, area is what it takes to cover. So if I were to want to lay sod in my backyard that is 20 feet by 30 feet, that's an area problem, right? Okay? Yes. So then I have what it takes around, I have what it takes to cover. Now it's time to fill that pool with water, right? So volume is what it takes to fill. So we're going around, we're covering, and we're filling it. Okay? So I'm going to redraw, because if I were to make this pool three-dimensional from here, my ground just became my wall, right? So do you guys know how to draw a three-dimensional? Yeah. Draw one square, and then the middle of that square, draw another square, and then connect these sides right here. Okay, so here's my floor now. So it's a 10 by 10, and for the sake of working with easy numbers, and because I have this nice cube right here, then I'm going to also make it 10. So I basically have a 10 by 10 by 10 cube cut out in my backyard filled with water. That's pretty awesome, right? So now, how much would it take to fill that? Length times width times height. So it's going to take 100, or actually 1,000 cubic units to fill it. So we call that cubic, because volume is cubed. Okay. Before we get into today's assignment, one last thing I'll talk about is I was humming or singing. Stop. I liked how the bottom of that tile looked so nice that I want it on the sides of my pool walls now. So, not obviously on the outside, because that's dirt, on the inside of it. So that's what we're going to talk about with surface area. Surface area would be, okay, it takes 100 of those tiles to cover the bottom, and now how many more of those, sir, do I need from Home Depot? 100 per side, and how many sides do I need? Do you tile the top of a pool? No. So I only need 4. So that would be surface area. I would be tiling this side, and this side, but not the top, right? So surface area is what it takes to cover the whole surface. Okay, so that's just a quick little blurb there. Now, let's apply that to what we learned today. I have a pool with a length of 3x plus 4 and a width of x plus 1. The Home Depot guy would probably look at me crazy if I went and said, sir, I may have a pool and I need some fence. And he said, what are the dimensions of your pool, ma'am? And I said, oh, it's a 3x plus 4 by an x plus 1. And then he would be like, you're a math teacher, aren't you? Because my kids are always saying, Mom, I'm always making math out of something. You know, like, oh, we have to be there in 20 minutes and it's only this time. How long do we have to get there? They'll be like, stop. So I want you, before I even talk about how to do this problem, what do you think the perimeter of that pool is? Go. Just think about it. Take a minute to let your brain kind of work through it. What would the perimeter be of that pool? And it's not just a number. It's got to have an X in it, right? So take a minute and see if you can figure that out. So, Tommy, what do you think?
I'm going with 4x plus 5.
Very close. But if he's going with 4x plus 5, then this person's only going to have that much of their pool fenced in. They're going to have the other two sides hanging wide open. I did it on purpose. So now does anybody need to adjust their answer? Okay. So if that's 3x plus 4, then that's 3x plus 4. And if that's x plus 1, okay. Anybody got an answer? Tommy, you want to give me another answer now? And here's how I would do it. If you have 2 color highlighters, I would recommend doing this today because watch, you may get confused or lose track of what you already added. So Ian, what do you have?
I got 8x plus 10.
Yeah. Because look, 3x plus 3x is 6, 7, 8. So I have 8x, and then where did Ian get 10? Because 4 plus 4 is 8. 9, 10. Got it? That's how you find the perimeter of a pool with math dimensions instead of regular dimensions. So here's your second shot at it. How about this pool is 8x minus 2 by an x minus 4. Okay? Go. Raise your hand when you think you have it. Can you fill in the other sides if you need to see them? Yeah, sure. If that's 8x minus 2, and if that's x minus 4, then so is this side. Okay, so Keegan, what do you got?
Is it 18x minus 4?
No. 18x
Minus 12.
minus 12. Anybody else get that? Okay, so watch up front. This is why I'm highlighting, because if I highlighted it, I already counted it. Because there's a lot to look at. You may lose track. 8x plus 8x is 16x, plus 1 is 17, plus another one is 18. 18x. Now, be careful because, watch, these are all negatives. Negative 2 plus negative 2 is negative 4. Plus another negative 4 is negative 8. Plus another negative 4 is, look how I'm going to write it. Negative 12. Okay, this will be the hardest one yet. Are you ready for this one? No, I think you are. Actually, this won't be the hardest one yet. I have another even harder than this. How about 2x plus 5 and x minus 3? Give everybody a minute to think about it. Remember, your answer has to be written as an expression, so it's got to have a plus or a minus in the middle. Yes. Yes. Okay. Who's not done one? Justin, go ahead.
6x plus 5.
Okay. Anybody else get that? Okay. So if this is 2x plus 5, so is this one. And if that's x minus 3, so is this one. You have to do a lot with that. So then I take a highlighter and I say 2 plus 2 is 4, 5, 6. So that's where the 6x comes from. And then this is what made it so hard, and I love that he knew to do this. 5 plus 5 is
10.
And then that's 10 positives, but negative 3 plus negative 3 is? And the tricky part was knowing that this is a positive 4, so you put a plus 4. Okay, so let's try this one. This is the hardest one. Okay, I want to make it, this is going to be steps, so this is going to be a nice little walk-in area. Okay, so I need that. So I need to fence this whole thing in. Are you ready? Okay. Woo, if you get this. These arrows mean that from this line right here to here, that distance is x. And then this is, you get it? Okay. I need your brain to take a minute and process that. So right off the bat, don't think you could just add what's there, because there's two sides missing. Right here and right here don't have anything on it. You're not lost. This is easy. You can do this. Listen. How can I figure out what that length is? Just look on the other side of it. Because if this from here to here is 8x minus 1, isn't that the same distance? So I want you to fill that in. Where else can I use that strategy? Ian?
Where it says X and 2 arrows.
Yeah. So if this is x from here to here, that's from here to here, now go. See if you can figure that. Boy, highlighters are very handy here. Yeah. Pay attention, Jake. Stop doing that. Curling your hair. I'll give everybody a minute to figure it out. All right, Dominic.
I got 34x plus 1.
No. Part of it's right, though. Part of it is right. Yep. Naya?
34x
Plus 1. So let's see where we got that. So watch. 8. I'm just going to go in order. 8 plus 1 is 9. 13. 14. 15, 16. And then this gives me 24. And 24 plus 10 is 34. And now, here's where Naya got 1 from. Positive 3 plus a, what do these two together give you? So a positive 3 and a negative 2 gives you a positive 1. Got it? Okay. All right. No, it's the area of the whole pool. Yeah.
I thought the 4x was a 4.
The what? Oh, you treated it like a 4 and stuff. That why yours were off 4 on both sides. Yes. Naya.
This shape kind of reminds me of the pool that I have at my
Yeah, there you go. Cool. Okay, now I'm going to give you this sheet. Actually, guess what? You already have it. Get your pink magic square out and flip it over. So flip your magic square, and you have those problems on the back. I got to show you a couple things, though. Yeah. If I have extra. This is why you guys, I literally gave it to you just yesterday. Like, where does it go in one day? Okay, so, a couple things here. I want you to put a star on this problem and this problem. You may not be able to do those problems, and I'll explain why in a minute. Then I want you to cross off all of the things that have a parenthesis in it. You will not need any of that right now. That's learning target 5, and we're not there yet. So you should have 1, 2, 3, 4, 5, 6 remaining. And then this one, not sure why, but is anybody else annoyed that they didn't just add that together? Yeah. So what would, yes, these are the answers. So what would you like this to be?
8x plus 6.
So there's an 8x plus 6 and an 8x plus 8, okay? Now, here's the tricky part for these two. If you can get this, that's awesome. But let me just show you this for a second, okay? If I were to say this whole side length is 8, and this side length from here to here is 3, what could you do to figure out what that side length is? Right? Because this and this together is, what would I add? So How the heck are you going to do that, though, for this one? Because I don't know that side length. But I know if this whole thing is 6x plus 4, and this is 4x plus 1, I have to subtract them. But guess what? That's what I just did today in my 8th grade advanced algebra class, 3rd trimester. So I don't expect you to know how to do that just yet. This one might be a little easier because this little space right here comes from here to here is 2x plus 4, and from here to here is 4. So what is 2x plus 4 minus the 4? Just 2x, right? That one was a little easier to figure out. That one, good luck. So if you can get these 5, I'll be happy. Okay? Here is the next part of